members today for our second training on the applications. Prior to the training, we have shared catalog links in the chat. Uh, Please go through it, download it if you can, as we will refer to it in our trainings. Right. So So what are we going to discuss about today? Some of the rules of engagement. Again, I want to remind, if there are any questions, please put it in the chat. Our team will get back to you during the chat itself, or end of the session. I will go through it, and we will respond to you. In today's session, we will take you through our factories. We'll take you through the applications. What this training does to you. Of course, it won't make you a specialist in designing the system. However, it will give you a guidelines on how to design a hot water system. And as you practice, as you design more and more, you gain experience. You make mistakes, you learn from it, and then you optimize your systems as it is and make yourself specialist. So let us begin the training today. This is regarding our factory. Before I start, Rim Manufacturing produces the commercial heat pumps in the Australia. We have a factory in Melbourne, which was established in 1939. We have offices in Melbourne. We have factory in Sydney. We have a huge factory. We are one of the prime manufacturers of heat pumps across the world. One of the specialists, you can call us, for producing such heat pumps. As we go through deep into the training, you will realize why I say our products belong to the top tiers in the market, and we hope you will gain some knowledge on the heat pump selection and sizing in the coming slides. Now, in terms of the product range, as we have people who are working in both markets of KSA as well as Middle East markets, which is 50 hertz, we have listed both our capacities in the screen. As you can see, for 50 hertz markets, which is all the MEA markets except Saudi Arabia. Saudi Arabia is 60 hertz market, so that will be a different product portfolio. So for 50 hertz, we have capacities ranging from 22 kilowatt till 248 kilowatt in the air to water heat pump segment. In water to water heat pump segment, we have for 50 hertz from 71 kilowatt till 213 kilowatt. For 60 hertz markets, we have capacities ranging from 75 kilowatt till 220 kilowatt in air to water heat pumps, and 70 kilowatt till 280 kilowatt in 60 hertz water to water heat pumps. As you know, these heat pumps cannot work as a standalone system. You need storage tanks. So we offer storage tanks from 500 liters till 30,000 liters from Italy. So when we approach a project, we design the whole system and we offer a turnkey solution, except for the pumps and pipes in between. We do supply everything. For those of you who are not present in our module 1, and also for those of you who are present in module 2, this will serve as a revision as to how heat pumps work and what's the main difference between air to water and water to water. Air to water heat pumps basically transfer energy from air to water, as the name suggests. So the energy across the evaporator gets absorbed by the refrigerant. Uh, from the ambient air, it absorbs the energy, and the refrigerant passes through the compressor, in which your pressure and temperature increases of the refrigerant, which passes through the shell and tube heat exchangers that has domestic water entering on one side and domestic hot water entering on the other side, leaving on the other side, thus exchanging the heat between the refrigerant as well as the cold water itself. The refrigerant loses its energy, goes to the thermostatic expansion valve, and then changes the state here and then passes through the evaporator, thus the repetition of the cycle. When it comes to the water to water heat pumps, the evaporator is replaced with the heat exchanger. So the water transfers the energy from one side to the other side of the system itself. The only difference is that the chilled water entering in the heat exchanger transfers the heat to the refrigerant, and therefore it cools down, and therefore the chilled water in is at higher temperature and chilled water out is at the lower temperature because it loses that energy, gives that energy to the refrigerant. Then the cycle repeats, goes to the compressor, again goes to the heat exchanger, where you have domestic water entering and hot water leaving, in which case the energy is being absorbed by the water and the refrigerant loses its energy, then goes back to the thermostatic expansion valve, and from there it goes to the evaporator. Thus, the cycle repeats until the temperature here is reached in the tanks. Now, what are the key features that you need to look prior to the sizing of the heat pumps? As this is the kind of benchmark that we normally ask people who are working on heat pumps. So, a couple of key features. Before going into the features, there is nomenclatures that I will take you through. So, remanufacturing manufactures heat pumps in three brands, which are Ream, Rude, and Richmond. We have two capacities. We have two types of heat pumps, which is air to water and water to water. Depending on the type of the heat pump, you will have the nomenclature set at the model. Then you have a nominal kilowatt that is rated by the factory that will be in these three boxes. We have evaporators. What is the type of the evaporator? Based on that, you have the nomenclatures here. We have refrigerant, and then after that we have the condenser. So the type of condenser defines also the nomenclature here. If it's a single wall shell end tube, as in case of water to water, also as a double walled condenser tube, the nomenclature is defined here. In case of an air to water, you will have it written as V because we use a coaxial vented copper condenser. Then different terminologies for voltages as well as some of the accessories that will come with the heat pumps itself. Now, in terms of the features of the heat pumps, we emphasize your air to water heat pumps to work at the maximum temperature as possible. This is to ensure that throughout the year, our customers get the hot water from the heat pumps itself. As you know, when we deal with heat pump systems, you also deal with the backup systems. We don't want our backups to work all the time because they are consuming a lot of energy. And this is why we want our heat pumps to work in the maximum ambient conditions. Um, Ream is one of Ream Manufacturing is one of the only companies that can supply you an air to water heat pumps that can work up to 52 degrees ambient. We also emphasize on the corrosion protection as well. As you know, we live in a very corrosive ambient conditions because of the salt content that is available in the ambient. This is why all our evaporator coils are specially coated with a coating called as ream coat, due to which it resists the corrosion itself. It passes almost 5,000 hours of salt spray test. After passing, we can see that the corrosion is very less. There's no corrosion on the heat pumps, thus ensuring that the heat pumps operate without having any issues of the quality. We also provide a stucco aluminum cabinet instead of the GI cabinets to ensure that in the ambient conditions such as ours in Middle East, this does not corrode at all and thus providing a longevity on the product itself. All the heat pumps that Ream Manufacturing supplies are with the Ream IQ controls that basically you can combine with different heat pumps. Up to four heat pumps you can combine and connect it in a series. One controller will communicate with the rest of the heat pumps. Um, Note that this is only applicable for a single model compressor units. When you want to do a modular installation, you can use a single model compressor heat pumps. Whereas when you have multiple compressor systems, you have a different control system that we help our consultant friends design. It has several features, including a lot of safeties, temperature settings, pump monitoring. You can also have BMS cards to monitor and to control over your BMS systems. So it becomes an interesting feature for property owners to have these kind of controls to ensure that their products are being monitored and works in the best possible design. Some of the features of the controller, you can again set the temperatures based on the outside temperature. You know, thermostat can control both water and refrigerant side temperature. Um, a lot of safety features across like high pressure switch, low pressure switch. If there is a low flow of water into the heat pumps, you know, it triggers an alarm as well as it trips the system, gives an indication to the end user to go and check what has happened. Also, it can connect to BMS through backnet or Modbus. Now, this is how a heat pump systems looks like. An air-to-water system. In this example, we have two air-to-water heat pumps connected via reverse piping to two tanks. As you can see, some of the parts or how the controller works. Uh, Basically, you have a sensor coming in from the tanks, which is connected to one of the controllers of the heat pumps. Now, this controller is connected to another controller, and that's why they have a single communication. Whenever there is a call to heat, you will see in the coming slides how the heat pumps work. But this is the overview of the piping. You have pumps, primary pumps connected to the heat pumps between the tanks, and so this becomes a primary circuit. And the secondary circuit is basically you have a cold water inlet and the hot water outlet and the hot water return coming in. How the call to heat works in terms of the heat pumps. So basically, heat pump determines that the call of heat is required. Then what it does is it energizes its hot water pump and the compressor and the evaporator fans, which starts the operation. So this is the primary pump that switches on when there is a call to heat. Basically, there are thermostat sensors that senses there is a requirement. So whenever there is a hot water that's being heated in the tanks and there is a demand, the temperatures in the tanks drop down because there is a cold water that is entering these tanks. And the sensors then detect that there is a call to heat, gives the signal to the controller energizes the evaporator and the pumps and switches on, and in that way the heat exchange between the ambient air happens in the evaporator and the cycle starts. There is a 20-second start delay between the starting of each heat pumps when a call for heat occurs. The hot water gets circulated between the tanks and the heat pump via the circulation pumps, as I explained. For a single pass of the water that passes through the heat pumps, the delta T that or the raise in the temperature is about 5 to 7 degrees, depending on the ambient conditions. So in this way, the temperature gradually increases in the tank, and that's how the heat pump operation works. And when the set point at the temperature is reached, you have your heat pumps and evaporators and the circulation pumps in the off conditions. And whenever there is a call to heat, again the heat pumps will proceed with the same process. In the water to water system, it's a similar system except for an additional piping, um, which is obvious because of the because the exchange of the energy is between water, chilled water. So you have water exiting the chilled water plant or coming in from your FCUs, entering the primary side of the heat pumps, and that will be probably at 14 degrees temperatures. It will enter the heat pumps whenever there is a call for heating for the water. What it does is the refrigerant on the primary water on the primary side exchanges the temperature from 14 degrees to 7 degrees. So it basically gives out that delta T of 7 degrees to the refrigerant, and the refrigerant then works in the vapor refrigeration cycle and gives out the heat, where you have on the primary side piping similar to our air to water heat pumps, where you have water on the other side as well, which exchanges the heat with the tank. So a similar setup as air to water heat pump, except for the fact that there is an additional piping on the primary side coming in from the chilled water. Let's go to the main training, which is for the sizing and selection of the heat pumps. Now, we have both 50 hertz and 60 hertz people. So whenever I am going through the 50 hertz, people who have downloaded the 50 hertz catalogs, you can refer to the 50 hertz catalog. And whenever I'm going through the 60 hertz, you can refer to the 60 hertz catalog. We have a limited time, so I'd like to keep the mic open for the questions in the end. So this is why I will give you a little bit basics. I will not be able to cover the whole base itself on the selection. And of course, this is a learning process. There are a lot of things to learn. Every project is different. So you have to work with that. We work with different consultants across the board. There is not a single system or single solution that we offer. It's a tailored solution. It's a customized solution based on the requirements in the site. So what we request is that for the selections, you reach out to our local sales team, who can help you, guide you better for all the selections. If you're once you are familiar with all the selection, then you can proceed with selecting the system as it is. So let us start. Now, there are some data points that we normally ask when we do the sizing and selection. Now, that is starting with the peak hot water demand. This is something which we always ask our customers, always ask our consultants, and all our mechanical engineers. So, a lot of different consultants follow different building codes. I have used ASHRAE as a base for our calculations today. But if you have any other standards that you would like to follow for us, you suggest something else, we can do that as well, based on the comfortability that the consultant has on those codes. So we always ask, first question is the what is your hot water demand, peak hot water demand? How much percentage of contribution you want that from the heat pumps? Some people say it's 75%. I want it from heat pump, 25% from the backup. Some say I need 100% from the heat pump, and I just need backup when the heat pump is not working. Um, then we ask the question, what is the recovery rate? If you don't know the recovery rate, then we suggest some of the recovery rates based on our experience. We ask where this project is. You know, for example, Saudi Aba is a very colder condition area. Riyadh is so different. So we ask this question to understand where is the units installed, so we know what is the performance that we look for in our heat pumps. So this is what we ask normally. We ask what is the ambient air temperature during summer as well to understand what is the contingency or backup plan for this. We ask what is the secondary side inlet temperatures during winter, especially. Um, then what is the type of heat pump you require? Is there a chilled water available? Is there enough space available? Can you install it on the roof? All these questions come across. If if you want a storage tank, what kind of specifications you want based on the budget, based on what the client is looking for. So we have that flexibility as we manufacture the tanks as well. Uh, and then we also look into all the nitty-gritties and then finally come to the conclusion of designing close to a perfect solution for your projects. So this is our inquiry check form. So in case you have a project, we normally share all these questionnaires, and then you can fill it up and send it across. So it makes our life very easy, and we can help you design a good solution for heat pumps hot water system. Now, a lot of times some of the good consultants give us the hot water demand. In case we don't have hot water demand ready, uh, we ask for the hot water fixtures, which they easily provide, which we calculate all the hot water fixtures available in that project, and then we list it out in an Excel sheet, and then we we start calculating as per the ASHRAE standards. Um, there is a table line that we refer from the ASHRAE hot water demand calculation from the ASHRAE handbook, and then we input those details into this Excel sheet that we have, where you have a total number of fixtures. This is total number of fixtures. Then for each fixture that is defined in that code, you have the maximum possible demand, starting from basins, food basins, showers, dishwashers, and everything. And then we multiply that with the maximum possible demand. Based on the type of the project, it defines you these values. Also, it defines the application demand factor as well as uh, the storage capacity factor. So you need to multiply these with the total, which will give you the total demand. Now, mind you, these codes that are there, these are all designed keeping in boiler systems in mind. The key difference between boilers and heat pumps is that they don't work in a similar way. The heating is completely different. Boiler system works on a quick recovery basis. All our codes are based on that. Whereas heat pumps, they have a slower recovery, slightly double recovery than the boilers. It is important that you need to have enough hot water stored to ensure that the heat pumps operate and there is less of a wear and tear. So this code basically defines peak demand in hours. So we have a duty now to select the recovery time, which I will take you through in the coming slides. So now we have the total demand calculated as per ASHRAE. As per this example, this is a hotel project, so I'm getting a 10,000 liter tank capacity. Now I have different ways of doing 10,000 liters. I can use one 10,000 liter tank, or I can use 5,000 liters into two tanks. And some people also do this kind of calculation where you have uneven balance of tanks, which is 3,000, 3,000, 4,000. We don't recommend using this system because this creates an imbalance, becomes a challenge when we are piping the system. So we prefer either to go with a single 10,000 liters if you are having a huge tank, or to go with 5,000 liters into two. Uh, Key points to remember at site is that what is the space that is available, what is the heat pump capacity that is available, and the tank capacities manufactured by the tank factory. Why I say that is sometimes when you do these kind of calculations from ASHRAE, you might get like 8,700 liter as total. And what we have seen is that without doing much of research, some people they just take 8,700 liter into one as a tank, or they divide it by two as 4,350 into two tanks. Now the challenge is that manufacturers like us, we cannot manufacture it exactly to that capacity, because we have a standard manufacturing production lines. So this is why you need to round it off to the tank capacities that is available in the market and that is being, produced by the manufacturers. So this is why it's important to go through the tanks catalog and also see what are the capacities available before doing the selection on the tanks itself. Now we have selected, let's say, I don't like to do 1 into 10,000 liters tanks unless, there is a space constraint and I'm forced to do it. It's easy to ship two 5,000 liter tanks. So I prefer two 5,000 liters tanks. We have now primary heating input, which will come from heat pumps, and the secondary backup, which will be electrical. Now, depending on the configuration um, of the heat pumps you select, the 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 position of the heat exchanger will change. So, in case you're using electric backup as a backup only, then the position will be slightly at the center. Um, but in case you want to use it as a boost, where to ensure that you have a certain degrees of temperatures that you want to reach from electric backup itself, then the position will be at the top and the heat pump will be at the bottom. However, this is an example just to understand where the primary heating input and secondary heat backup element will be. In my example, I'm using electric as a backup only. So I need to know four different things before I calculate the input kilowatt. First, storage capacity in liters. I need to know what is the domestic cold water in, especially during winter, because this is the time when people use a lot of hot water and your heat pumps needs to be designed for such conditions, because this is the extreme conditions of heating. Then you need to also know what is the domestic hot water out, and then the recovery time. Okay, so recovery time is a very interesting topic, because we always get so many questions on this. How do you decide the recovery times? Now, typically, let's say, because we get a lot of inquiries on hotels, we know the energy or the heating demand is mostly on the three peak loads, which is morning, afternoon, and evenings. Typically, between the first peak as well as the second peak, which is morning and the afternoon, there is a gap of at least 3 to 4 hours, which basically is your time to recover the hot water. So, depending on the number of peaks that you have, you will have to decide your recovery time. We do not recommend recovery times to go beyond 6 hours in commercial projects. Um, but there are cases where we have designed it between 3, 4, and 6 hours, depending on the various site factors. So let us decide for the sake of uh, calculation. There are certain recovery times that I have assumed in this, and then we proceed. So first, I will do the calculation on the electric backup, because this is common for both 50 hertz and 60 hertz, so I don't have to repeat. Now, primary heating input will be my heat pumps and secondary will be elements. So I will use this formula, which is capacity of the tank into Cp, which is specific heat of water, into hot water out minus cold water in, which is my delta T, divided by 3600 into recovery time. Whenever you're doing electric backup sizing, always size it for 4 hour recovery, because your backup only works when your heat pumps are not working. You don't want to oversize it by sizing it at 1 hour, 2 hour, because then the whole purpose of saving energy is lost. So this is very important to size it maximum up to 6 hours, depending on the project. So for this example, I've considered 4 hour recovery time, in which I will get a total kilowatt required for 10,000 liters, about 130 kilowatt. I have two tanks, so each tank will be having 65 and 65. So that's how my electric backup is calculated. Let me go to the heat pump calculation. Now for heat pumps, you can have a recovery time because this is your primary heating and you don't want to risk your system to either having a higher recovery time or a very faster recovery time. Faster recovery time, 1 hour recovery is not possible, or we don't recommend having 1 hour recovery because heat pumps need a certain time of operation. And when, let's say, if we design it for 1 hour recovery, then and the storage is also less, if the heat pump there is a frequent switching on off of heat pumps, then there is a lot of wear and tear. We want to avoid this situation because this is an investment made by the client and we want to have the maximum operational life of the heat pumps. This is why we recommend to go for 2 to 4 hours of recovery. In my example, I've used 2 hours of recovery, of which I need 262 kilowatt of energy to raise from 15 degrees temperature till 60 degrees. That's about 45 degrees of delta T for heating up to 10,000 liters of water. Now you have two options to select. The step four is to select the heat pump. For those of you who missed to download the data sheet, you can download from the QR code or the chat itself. So we have two options now, air to water heat pump or water to water heat pump. Now for water to water to work, I need to have a water source from which I can extract energy. My water to water heat pumps works from 12 degrees up to 35 degrees on the primary side. So if I have anywhere a water which is in this range, I can use this water to heat my water on the other side. So it could be some of the examples could be chilled water plants, recovery systems, etc., etc. So and also you need to have enough flow rate to provide it for the heat pumps, for the water to water heat pumps. Water to water can be installed indoor in tight spaces. It can be stacked upon each other. So you have a tight space, you have a chilled water, for example, then we propose um, a water to water heat pump system. You have a larger roof space, go for air to water because air to water is the best solution. It can work throughout the year. It can work up to 52 degrees ambient from 0 degrees. So it's one of the best systems that you can offer if you have enough space outdoor. Again, decision is made based on the site to site. There is no hard and fast rule that you can have to use this, you have to use that. Based on what is availability in the site, we can tailor the solution and provide as per this. Let me first go to the 50 hertz selection. So that will be at water if I have to do it for 50 hertz. Then again, these are the 8 primary capacities I have from 22 kilowatt till 248 kilowatt. Our heat required was 262 kilowatt as per 2 hour recovery time. So I need to find my capacities based on the heat pumps that I have. There are multiple ways to do it. Again, there is no hard and fast rule. This is just a way. It's just the basic guidelines that we do it. So you are free to play around and come up to your own conclusions, and we can then validate that based on that selection. If you have downloaded the 50 hertz catalog, please refer to page 24, 28, 32, and 36. So if you open a page 24, you will see a table like this on a 50 hertz catalog, which will look something like this. If you open page 28, it will be for 124 kilowatt of heat pumps. The table of COP will be given. And 153, which is page 32, and page 36, that will be 188. So I've just taken the screenshot of that table. I will explain to you what is this table. In the x-axis, which is the top header, you have ambient temperatures. and in the y-axis, which is the in this column, you have water out temperatures from the heat pump. For our conditions, which is 15 degrees in and 60 degrees out, I have marked in two boxes, right? Now, the corresponding value that is going to come, that is the heating output that you're going to get in that condition for the heat pump. So what this table suggests is that for different ambient conditions, for different water out conditions, you have different heating output. This is how the heat pump operates. So in this example, for example, 96 kilowatt of our heat pumps, which is the nominal capacity, we are getting at the ambient conditions that I require during winter, I'm getting 71.32 kilowatt of energy. Same goes to 124 kilowatt as well. I'm getting 93.25. 15 and 60 in 153, I'm going to get 116 kilowatt with the COP of 2.95. And 188 kilowatt, I will get 140 kilowatt. Now, my required heat pumps are 260 kilowatt. So I cannot suffice it with a single heat pump. I will have to go through two or three or four, depending on what kind of freedom we have in the site. We can either design it as a modular concept where you have single compressor models multiplied with the multiple tanks, or we can go with the minimal capacity of the heat pumps. In my example, I am taking 188 kilowatt because this is the maximum I can. If I use 115 kilowatt, the maximum 2 units will give me is 230 kilowatt. If I use this model 96, it will be 140. If I use 124, it will be 94 kilowatt into 2, which will be 188 kilowatt. The only heat pump with this kind of configuration will be 188 kilowatt. That will give me 140 kilowatt each. That is 280, which is higher than what I need. So I will select RMHW or RTHW or RUHW 188 kilowatt. Now, what most of the engineers need after selecting the heat pumps is what is the maximum electric consumption. This is something which needs to be calculated by the engineers whenever they are selecting the heat pumps. That's because most of the times our heat pumps will be operating in a certain conditions, and this is why you need to consider the maximum available maximum energy being consumed. So what we suggest is that we have that list. If you want, anybody needs to know, you can either calculate it. So how you calculate it? Basically, in the same tables that we have, there is a repetition of there is a value given for 52 degrees C ambient and the maximum temperatures that the heat pump can achieve, which is maybe 70 or 65, depending on the model you are selecting. You will get the heating capacity and the corresponding COP. You divide heating capacity with the COP, you will get the maximum kilowatt of the electrical consumption that is there. So that we have listed in this model itself. So for this model of 180 kilowatt, you will have 56 kilowatt of energy for the single unit. So 2 units will be 112 kilowatt. Summary of our selection, as you know, 5,000 liters into 2. We have heat pump selected as 188 kilowatt model, 2 numbers. And then we have electric backup, which we calculated earlier to about 65 kilowatt, 66 kilowatt. Now, during some of the people ask us what is the maximum connected load when you're doing a backup system, electric as a backup. We always select which is consuming the highest energy. So in our case, it is electric backup because only one of the modes of heating will operate at a time. So when the heat pump is not operating, electric backup will work. When the electric backup is not working, heat pump will work. So that's how this system is designed. However, we can also design some other systems where in certain times you want electric backup to work, we can design it in such a way that only electric backup will support the systems as well with the heat pumps. So different principles we can follow based on the site conditions and the project. For 60 hertz, um, if you have downloaded the 60 hertz catalog, please refer to page number 14, page number 17, page number 20, and page number 23. You have a similar capacity of the similar tables that is being given. You have four tables. Um, it is the same concept as our 50 hertz, just the values of the tables are different. I need 262 kilowatt of energy. So I will then see if I need to use 2 units of these heat pumps, which one to choose based on the tables that we have. The best table that can suffice my requirement is the 180 kilowatt heat pumps, which will be 280, which will give me around 286 kilowatt of energy to two heat pumps, which will be covering our 262 kilowatt of requirement. Same process we follow for the electrical consumption as well. Go to the same, there are two tables. Go to the table which shows for 52-degree ambient and the maximum hot water output, and the corresponding value you need to take. You will get thermal load divided by the COP that is there. You will get the maximum electrical kilowatt for the heat pump that you selected. This is a summary for 60 hertz. A similar calculation that we did earlier. Um, you have the tanks, you have the heat pumps, you have the electric backups as well. Now, so you have done the air to water heat pump selection. Let's go to the water to water heat pump selection. For 50 hertz, the capacities are from 71 to 213 kilowatt. Uh, Things to keep in mind when you are selecting the water to water heat pumps is that you need to know what is the chilled water system that you have, what is the delta T that you can give us for the heat pumps. For example, what is the return temperature? Some say it is 12, some say it is 14, some say it is 16, depending on what is the design. Uh, if you have a cooling tower, maybe you can get a higher temperatures as a return and connect it to our water to water heat pump. So it can reduce a little bit of load on your HVAC system as well. Uh, Again, the temperatures vary from on the primary side from 12 degrees to 35 degrees. So you have that flexibility to choose. Similar to our air to water tables, you have water to water table as well. You can refer to, if you are on a 50 hertz catalog, it's page 48, 52, 56, and 60. You have a table like this. Um, so you have cold water in as an x-axis. This is the primary side temperatures. You have hot water out, which is the secondary side temperature that you are desiring. For example, if you are desiring that your chilled water return is at 14 degrees, always at 14, and you want a 60 degrees out of the tank as a desired temperature, then you will mark the corresponding capacities in the catalog and do the same as how you did for air to water. Whichever suffices the requirement, you select that. In this example, you have 176, again 176 kilowatt model sufficing about 143 kilowatt of energy, which will be enough. 143, 2 units of this will be enough for heating up 131 kilowatt into 2, which is 262 kilowatt, which we calculated earlier. So this is the selection of the 176 kilowatt. And the summary, we have two tanks and two water to water heat pumps. Two tanks come with an electric backup of 66 kilowatt. Similarly, for 60 hertz models as well, we have different capacities to choose from. Page 28, 31, 34, 37 will give you these tables. You can refer to it. Cold water in is at the x-axis, hot water is at the y-axis. And then based on the conditions that you are having at the site, you select the capacities that you're looking at and select the heat pumps. In our example, we use a 175 kilowatt, um, and the electrical consumption maximum is about 58 kilowatt for each heat pumps. Summary of the system: we have two 5,000 liter tanks with electric backup and a 175 kilowatt of water to water heat pumps. Some of the important key reminders: you need to also take care of plumbing system, plumbing design, which we have not covered in this session. Uh, First reminder is that always, whenever you are sizing a pump, circulation pump, please ensure the flow rates are as per the specified capacity. Um, why is this important? This is important because this is how our equipments are designed, our heat exchangers are sized. If the flow rate is less, if the pump head calculation and flow rate calculations are less, the problem is that we will have a lower delta T, which will trip the units quickly. And this is why we don't want that to happen, and we want specified flow rates to be followed. So all our catalogs, they have this section in the catalog where you can see easily our flow rates. For water to water, there are two flow rates we specify, which is primary side pump and the secondary side pump. For air to water heat pumps, we specify only the primary side. So that's on the circulation pumps. On the space, we understand a lot of times you want to save space. There are constraints across the board. However, certain requirements are mandated by us. There are some exceptions that we follow depending on the sites and design. However, as a standard, we suggest that there should be at least 1 meter to 0.85 meter of clearances across the heat pumps, just for the sake of serviceability, also to ensure the airway path is not blocked. So we recommend this kind of recommendation. In case you have multiple heat pumps, you need to also, if you are facing an evaporator side, we recommend 2 meters of distance between the evaporators, just to ensure enough airflow is there between the heat pumps. Also, if you want BMS, please specify it to our team, because by default we don't supply BMS cards. In case you need it as a requirement, you need to ensure, you need to inquire about it, and we can offer it as an optional accessory with our systems. Case studies on the uh, different modes of energy. I've taken through some of them in the basics. It's a revision for people who have attended that, people who have just joined in for this. This is easy to understand. So electric calorifiers, the initial cost and the installation cost is lower compared to your heat pumps. Heat pumps and the systems are a bit higher because of the plumbing as well as the components itself. Whereas the operational cost for the electric calorifiers are very high, and this is why water to water heat pumps and air to water heat pumps gives you an ROI of 3 years compared to electric, 3 to 5 years compared to electric calorifiers. Um, so operational cost is 70% lower. In terms of efficiency, as you know, maximum 93 to 95% efficient if maintained well, whereas heat pumps are 400 to 600% efficient. Carbon footprint for calorifiers is higher. Um, for heat pumps, it's lower. Solar force circulation system, compared to air to water heat pumps, the initial cost is higher compared to the heat pumps. Installation cost is definitely higher for solar compared to heat pumps. Maintenance cost again higher compared to the heat pump systems. Efficiency wise, solar systems are about 50 to 60% efficient. This is the maximum any panels can achieve. Um, as you know, as there are losses, irradiance losses across the board for the solar panels, whereas heat pumps are more efficient. The space required is higher for solar. Of course, a lot of people who have dealt with solar, they know, especially for projects like hotels where you don't have enough space over the roof, solar becomes a problematic proposition. Installation for solar is always outdoor, whereas heat pumps can be installed indoor and outdoor. And of course, solar is dependent on the solar energy. So during winters, when we don't have enough solar energy, it is difficult to gather heat from the sun itself. Boiler systems, as you know, a lot of hotel chains across the Middle East are concerned about the sustainability. So it's important that we show here a comparison between boiler systems as well as heat pumps. So initial cost for boilers and the heat pump systems are similar. Installation costs is high for boilers because you need to install safety accessories, chimneys, a lot of controls. So it becomes a challenging task for installation. Whereas heat pumps, they are fairly simple. Just you need to worry about plumbing as well as some airflow requirements. That's all. So it becomes an easier proposition for installation. Operational wise, boilers are higher depending on the region that you are in. Most of the regions where we have done the case studies, what we have seen is the operational cost for boilers are very high, whereas heat pumps are very low. Environmental impact, again, higher carbon emissions for boilers. You have lower carbon emissions due to higher COPs for heat pumps. Efficiency wise, heat pumps are highly efficient compared to boilers. In terms of installation, again, it's easy to install heat pumps compared to boilers. People who have dealt with boilers, they know, those tough talks with their architects where they have to design a chimney system to dispose of any flue gases. So it becomes a huge task for them, whereas heat pumps are fairly simple. Maintenance, you need a very specialized equipment supplier for maintaining boilers, whereas heat pumps are fairly day-to-day day-to-day system that is being used in each and every parts of life, in such as AC. So you have a lot of specialized people doing the maintenance, so it's easier as well as the skill-wise, it's easier to find them, and also to maintain a heat pump is much simpler than the boiler. We've also put in across a comparison between thermodynamic solar system. Um, the initial cost for the thermodynamic solar system is higher compared to the boiler system, to the air to water heat pumps. Ease of installation, it's easier to install a heat pump compared to a thermodynamic solar, which is, of course, a similar system as the heat pumps. The only difference is that you have evaporator coils that are separated as a solar panel or a solar thermodynamic panel, and then you have to do the piping separately to the compressor and the condenser and all of those. Whereas heat pump is a fully integrated system, all by itself. So you have to just install it to the plumbing. That's all. So it becomes very easy to install air to water heat pumps. Refrigeration piping for thermodynamic systems is required at site, whereas for air to water system, it is not required because it is factory built and factory filled. Uh, Serviceability point of view, it is difficult to service and rectify a thermodynamic system in case there is any leak in the panel because this is exposed to atmosphere. It is so difficult to find the leaks, and therefore becomes downtime is higher compared to the heat pump systems. And space as well, you would require a higher space compared to traditional air to water and water to water heat pump system. That's it about the case studies. I'll open the floor for questions. Please raise your hands, and our admin will be giving you access to the mic, and then you can ask your question.
Hi, Mohammed. My name is Ramesh.
Hi, Ramesh.
So thank you for the wonderful presentation, first of all. So my query is actually for the regarding the backup. So how much how much percentage of backup do we need to consider uh, for the heat pumps? Basically,
For a
it's a
heat,
water to water to water heat pumps, basically.
right, right. So what we suggest is that you can select for a recovery time up to 6 hours.
Okay.
What I mean by 6 hours is that, for example, if you're using it as electric backup,
Mm-hmm.
so you have a flexibility to choose, right? So you can do it for 2 hours, 4 hours, or
Mm-hmm.
6 hours.
Yeah.
6 hours will have a lower kilowatt compared
Correct.
to a 2 hour. So you
Correct.
have that flexibility depending on what you are looking at and what you're comfortable in.
Mm-hmm.
Normally I do a 4 hour backup always
Mm-hmm.
because if for whatever reasons my let's say water to water heat pumps during
Mm-hmm.
winter you might not
Mm-hmm.
have a chilled water flow, right?
Correct. Yeah.
So in that case, my heat pumps won't operate, but I
Yeah.
still have to suffice my peak load. So what I need
Mm-hmm.
to do is that if it's a hotel, for example, I know that
Yeah.
my first peak is in the morning, second peak is in the
Mm.
afternoon, third peak is in the evening.
Yeah.
So I have 4 hours gap between these three peaks, so I can
Okay.
recover that water during that
Mm.
time. So I will select
Mm.
based on that.
Mm-hmm. Okay. So, so we have just done a case study on one of our project. So, in the that's in the Riyadh, of course.
Hmm.
So, in that case, we have studied that adequacy of cooling load from the children during the winter. So, we have taken us 5 a.m. in the morning. So, at that time, we had found that we have adequate cooling for the from the chiller. So
Hmm.
then do we need to consider the backup for that one?
Uh, Again, it depends, right,
Mm,
from site to site, project to
mm,
project. We always suggest have a electric backup in the system,
mm, mm-hmm.
just in case, if there is any downtime,
Yeah.
because you have a criticality, right? You have
Correct.
again the guests are there,
Mm,
people need
mm,
hot water in any case. Even if you
mm,
don't connect to the grid, it's fine. But we
mm.
suggest every time we do a sizing, you have electric backup.
Okay. 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 Thank you.
All right. Thank you.
I have simply just one question. You didn't mention about the sizing for direct heating, not just for storage. How can I size it?
So, unfortunately, heat pump systems, we don't have a direct heating. It's only with the boilers that you can do a direct heating system. You mean, are we talking about the space heating or are we talking about the
Yes,
uh,
space heating.
space heating? Okay. If you have a space heating, then this sizing is completely different because this is mostly we talked about hot water systems, right? So when we do a space heating, then we will have a buffer tank that will take care of the volume of the space that you're heating. It's a different principle, but we didn't touch upon it in this session. We can maybe discuss it in a separate platform. However, if we are talking about heating the water without the tanks and with the heat pump, it is not possible because For a single pass system like heat pumps, or for a multi-pass system like heat pumps, you need to have storage. You cannot run water in one side and get, like, let's say I run water at 20 and I need 60 degrees on the other side. It is not possible to do that with the heat pumps. Such technology has not yet still come to the heat pumps. It's there in boilers, but not yet in heat pumps.
Then I can make the space heating by the storage.
Yes, so you need to do, when you do a space heating, if your delta T is smaller, 7 degrees, you can still use a direct heat pump to do that. However, if your delta T you are saying is a larger delta T, where you have, like, let's say 5 degrees temperature and you want to increase it to 25, then there is a buffer tank that we size it in between the system, and then you can pipe it across that.
Oh, okay, thank you.
Okay.
Hello, good morning.
Hi, good morning. Yes, sir.
Yeah, thank you very much for the great presentation. Actually, I have one question for using heat pump for hospital application.
Yes, sir.
Actually, in hospital project, when we design the hot water and if we follow ASHRAE system and application table, we first will got the demand per hour.
Correct.
And in this demand, we already consider the demand factor. So it means what we got liter per hour, we already consider the diversity. And
Correct.
now we reach to demand per hour, liter per hour. And after that, we apply the storage factor, which like 0.6. So it means I am storing less than what I need per hour.
Correct.
Correct? So as per your calculation here, you consider recovery like 2 hours. So
Correct.
first I need to know, is there any code reference like ASP or any code that allow us to use for hospital application 2 hour? And the second thing, now if I use 2 hour, it means I will not able to provide the probable demand liter per hour, which required as per calculation.
Right. So there is no such codes for recovery time at the moment. I mean, we've been talking to IPC, we've been talking to ASHRAE on this topic. Currently, we haven't had any sort of response on this, unfortunately. So we are down to currently using the old codes as it is, and then estimate based on the experience that we have. So because Ream Australia also does a lot of hospitals across the globe. Uh, what we have done is we have taken some data across, and based on that we select the recovery time. We share that calculations with the consultants, and use that. I understand your question coming in from the standards point of view, but unfortunately, currently there is no regulations coming across for the recovery time itself. So we'll have to stick with the practical appliances, or practicality that we have, or experience that we have on sizing the heat pumps for the hospitals itself.
Yeah, but based on your experience in project here in Saudi Arabia,
Yeah.
for hospital 2 hour recovery, you didn't receive any feedback from operation team that they have any problem for that.
Unfortunately, we have not designed anything for currently with the hospitals. We have a couple of projects that we currently designed, specified, and about to be supplied. And we will gather that feedback from the site, and then we will make our decisions for future.
Okay, thank you.
Right. So,
Hi, Mohammed. Thanks for the presentation. Can you hear me?
yes, I can hear you. Is it Anita?
Yeah, Mohammed.
Yes. Yes.
Hi. Just wanted to know, like, how many inlet and outlet connections we can make to a heat pump. Like, sometimes, like in summertime, we'll be connecting the chilled water return to the heat pump, but in the winter time, the client is suggesting to connect to that to the main water tanks, where we can get some heating like that. So, is that possible?
It is possible, but cannot directly connect it. You have to do something in the plumbing. You need to use a sort of a four-way valve
Mm-hmm.
that can be used in between the chilled water return tank and the heat pump. So basically, this four-way wall will divert the flow. For example, if you're using it during the summer, you can use the chilled water line, and that will operate. The four-way wall will operate in such a way that the flow is directed from the chilled water line to the heat pump. And during winter, you can use the other way around, where you can use the tanks to cool and uh, take that energy for the heat pumps to heat the water on the other side. But
Okay,
for
so
the
but inlet and outlet is one. Yeah. Okay.
yeah, exactly. Inlet and outlet is one, but you can use a four-way valve with a controller that you can have. I mean, we design it by itself, which can sort of do this programming.
And okay, fine. And you have mentioned like in some heat pumps like 70 degrees we can deliver the hot water like that. Is there a standard approach or like any specific any special refrigerants we need to include for that?
So we use R134A refrigerant. Some of the models that we have can go up to 70 degrees in R134A. And most of the manufacturers across the board, they if they use R134A, they can achieve it. However, some of the models we have a restriction on the compressor envelope, so we can't go beyond 65. So, depending on again which model we are talking about and which refrigerant, you can easily achieve that.
Okay, so while doing the heat pump calculations, like it is safe to go with 60 degrees as the temperature. It's
Yes, 60, 65. Yes.
okay. All right. Thank you. Thank you.
All right.
We have mentioned the sizing of the heating coil by the both the hot water and the cold water, but we didn't take into consideration the weather conditions. Like in some weather in winter, we have cold range and normal range. So at which condition you have size?
So I've considered which is like the colder side in some of the places. If you have a colder region, which is let's say 5 degrees or 10 degrees, we go to Abha in such places, then the selection will be again tailor made for such conditions. But for my example, I chose 15 degrees as ambient.
Okay.
Okay, thank you.
Hi, Zishan.
Hello.
Hi, this is Adib. Okay, thanks for the presentation. I had one question for this one, heat pump, water to water. Um, the connection from the chilled water air cooled chiller, chilled water return will connect to the heat pump. So we have 12.7 degrees centigrade. And while the heat living temperature of this chilled water return from the heat pump, what will be the delta T on the temperature?
Roughly about between 5.5 to 7.5.
So if I have 12.7, delta
Yeah.
T itself 5.5, you're saying.
Yeah. Delta T will be 5.5 to 7 degrees. 5 to 7 degrees.
5 to 7 degrees.
So you can
Okay.
minus that value from your inlet.
Okay, then this chill water return I'm giving to the heat pump, and again I need to connect to the chill water return itself, right? Not to the supply.
To the return. You'll go back to your chiller. It will go to your chiller.
Okay. In between, I need to have any this circulation pump for that.
Yes, there will be a primary pump. Yes.
Okay, but how we can calculate this one? Is
So you don't have to
based on-
calculate it. You will have this. So if you have this catalog, you can see on the screen there is a flow rate excluding bypass. So this will be hot side. This will be cold side. So on the evaporator side, which is this is the flow rate that we need for the water to water. Okay. And then you calculate your frictional loss. Any pump manufacturers can do it for you, or if you want, we can do it as well. So you give us the piping that we have, what is the diameter, what is the fittings, what is the valves, and then we do the head calculation and then specify the circulation pumps for you. But this is the flow rate that you need to typically consider when you size a heat pump.
Okay. Okay, thank you, Zishan. Thank you.
All right, perfect.
Hi, Zishan.
Hello.
Yeah, thank you for this presentation. I had one question that since we are connecting the heat pump directly to the water, okay, that is maybe the water in the calorifier tank. Will it
Yeah.
not be detrimental to your life of your heat pump, or it will be
Yes, it
able to
will
take?
be.
Hmm.
Yes, good question. So what we typically do is we define the water conditions that we look at. Whenever we size or design a system, we ask for a water quality report, or we estimate it based on the site. Now, if, for example, if we see that the water is very hard, and there will be scaling, we recommend to use a closed circuit, which means we can provide you with the coil, internal coil, or a YouTube bundle, and then we will size it accordingly. We'll size a heat exchanger in between, and we will ensure that the heat pumps will, not have any problems. I hope I answered your question.
Yeah. So understood. So you're saying that in case the water quality is not as per the standard that you follow, you would have a coil bundle.
Coil bundle,
It's a
YouTube
closed
bundle.
circuit
Yeah, it's a
or
closed circuit.
a heat exchanger. You're saying.
Yes, yes.
Okay. Okay. Understood. Okay. So typically with a what do you say, a filtered water or a, what would be the life with this normal water quality, which is it is meeting the requirement of your heat pump? So what would be the life then generally?
So generally, we say that the product life cycle for the whole system should be 10 to 15 years. Is 10 to 15 years. Given
Okay,
you
so
maintain,
directly
given you
connected.
maintain your water filters. Yes.
Okay, okay, understood. Yeah, thank you.
Oh my, it's a lot. It's a lot.
Mr. Hassan, you can ask your question.
Hi, thank you for this nice presentation. Actually, my question is one of your the slides you have mentioned that it can withstand up to 52 temperature. This air to water heat pump.
Yes.
Okay, so are we able to install it exposed on roof,
Yes, of course, you can.
or do we need to have some preventive measures like shading or some sort of cladding or?
You can install it in the roof with the exposure to the ambient, because we provide a stucco aluminum cabinet as a cover for our heat pump. So, and it is tested for such conditions. So you can install it outdoor.
Thank you.
Right. Okay, I think that's it for today. Thank you so much. You've been very. Okay, there is one question. Last question. Then we wrap up the. Mr. Abdullah, you can ask your question.
The mic is allowed. You have to unmute from your end.
Sir Abdullah Mahmood.
Abdullah,
Could we have this session recorded, please?
Yes, we can. Depending on your geography you are in, you can reach out to our sales team. They will help you with the recording.
Okay, much thanks. Thank you.
All right. Okay. We wrap up today's session. Thank you so much. You've been a very patient listeners and a lot of good questions. So I hope I've done justice to the subject. You can reach out to me anytime you want in case you have any questions on heat pumps. We are really happy to help you. Our sales team members are across the GCC and Africa. So feel free to reach out to them as well. We do a lot of stuff in water heating, ACs. So in case you need any sort of support, we are ready to support you. Thank you for joining.
Thank you.